Welcome back to the Quirky Sound channel. In this video we're going to be having an update on where I've got to with my very simple clock divider. I'll just stop the sequence running. The patch that you've got going there, it's a little bit overcomplicated for what I really need to demonstrate, but if you remember, the clock divider, the idea for the clock divider was to kind of try and, it's a series more about learning why circuits work as much as kind of getting a circuit that does work after a fashion, as you'll find out. So we started with, we've got the 4017 decade counter, which by altering at which count it does the feedback, we can kind of get a clock division out of it. But then looking at what is kind of the common practice of synchronizing the main clock input with the clock output, the divided clock output, and doing that by using an AND gate such that you've got to have the clock input and the output before you get the output at the final output. And I looked at using discrete AND gates rather than a logic chip. So with the first design was 2 transistors, which sort of worked, but when I put it into a clock divider circuit, I got some weird effects that I wasn't happy with, so I binned that one. And then last time round I looked at using 2 diodes to produce the AND gate, and then in the last video, which kind of, yeah, we got that working alright. Then in the last video I showed you the panel that we've got up here, actually now installed in Project XII. So yeah, on the panel we've got the clock input, we've got the divided clock output, we've got a rotary switch control for setting the point at which it resets, so the length of the delay before you get the next output. I wired the 2 diode AND gate into the system and put a switch on so I could switch the AND gate in and out, and then I've got a reset, which basically means it just, you hit that, it will always go back to the start of the clock divider counting. If you actually hold that in, it just hits every time. What I've got running at the moment on this sequence, if I start it going again, so what you can hear now is from the beat step control, I've got the trigger out, which is triggering a kick drum, but then that trigger is also going into the clock divider. Out of the clock divider it's driving a Vactrol, which is fed from a white noise generator, which is giving you the shushy percussion type sound. The white noise generator, it's filtered, so it's going through a VCF, so I can actually change the sound of it. It doesn't matter for the purpose of this demonstration. It doesn't matter what sound we've got on it. So if I turn the control at shorter pulses, you can hear there's some kind of randomness thrown in every now and then, and that's because we've not got this synchronization between the clock input and the clock output. So if I switch the AND gate in and see what happens, pretty much not a lot really, and I wired it up as I showed in the last video. Now I do have a theory as to why that probably isn't working. Circuit for you. I think part of the problem and the reason that I'm not getting the nice neat tie-up is that in the last video I talked about the fact that you had to have, and this is the diode AND gate, so I talked about the need to have a matched voltage for the on both ends of the diode for there to actually be no current flowing through it, but also you had to have a nice clean true zero logic, as in ground, for the current to flow, or at least a resistance that was much lower than the alternative direction, which is the output. And if you remember, when we left one of the inputs just floating, so you got the high resistance of the air, current couldn't flow, so you even though there was actually no signal on the logic gate input, you were still getting an output, when you shouldn't do in an AND gate. And I think that the circuit I've got, the voltages and the groundings are not what they should be. So what I'm ending up with is something that doesn't fit the theory of the design. So is it a reset, which basically just resets it on every clock, so you should just get a shush out of this. Because it's just kind of hitting every time, so you just basically just hearing the white noise. And another quirk that I discovered, as I turn through the rotary switch, we get a slower response, and you're still getting that kind of that discrepancies in the signal where it gets completely out of sync. Slower again, and then when I get to the last position on the switch, I get the same effect as hitting the reset button. And for that one, I have absolutely no idea why that's happening. If I turn it back, then we're back into its kind of normal, if somewhat slightly quirky operation. So there we go. That's kind of where I've got to with my oversimplified clock divider in the panel. And the other thing that happens, it didn't happen there, but sometimes when I stop the sequence running, if I stop it when the clock divider is firing, it doesn't cut off afterwards. It just keeps going, and I have to trigger it again, hit it with a trigger signal again to stop it. Or one of the things that I can do is, if I actually short the input, it will stop. So have I managed to build an ultra simple clock divider? You could argue I managed to build a clock divider that's too simple and therefore is not accurate, is not always predictable, and therefore as an accurate predictable clock divider it's a failure and not really very useful at all. On the other hand, what I've produced is a clock divider with some quirky features. A little bit of unpredictability, a little bit of randomness thrown in there, and some other things that, well, yeah, could be useful, maybe. The more I actually build modules and circuits and try them out in this DIY system, and they don't do quite what you'd expect a commercial version of that particular module to do, I'm starting to get the idea that actually if I wanted to do what a commercial module does, then go and buy a commercial module. You know, and it's the same with this clock divider. If you want a nice clean precise clock divider, do not build this circuit. It doesn't work in the configuration that I've got it in. However, if you want to experiment with some quirkiness in your improvised electronic music, which basically is what I'm about with these modular synth systems, if I wanted to play a nice, clean, precise synth, then I would go and buy something that somebody spent a lot of money working out, and these days you can pick up for not silly money, depending on whether you want to go down the full modular route or buy a pre-patched Korg or whatever. Many other brands are available. I am not promoting anybody's products here. However, if you want to experiment and experiment with something that you built, you put together, you discovered its quirks, its quirkiness, and then built that quirkiness into the expression that you put into your electronic music improvisation, then don't view these things as failures. View these things as a nice unique tool that you can use in your music that gives it something that you wouldn't get out of your nice, clean, precise commercial product. Something different, something yours. So if you want to do something different, I've given you kind of the basic circuits and some of the layouts in the previous videos, so yeah, go on, why not? Have a go. Build your own.